My name is Cynthia Zastido, and I'm excited to present our work exploring the use of generative AI to support automated just-in-time programming for visual scene displays on behalf of my co-authors, Christine Holyfield, Christine Kapp, Zandria Crossland, Elizabeth Laura, Tara Zimmerman, and Stephen McNeil. Visual scene displays, VSDs, are a form of augmentative and alternative communication, AAC, device which use images with interactable hotspots placed on them to represent communication options. VSDs are particularly useful for beginning communicators, those learning their first words, because they introduce language in personally relevant contexts. On this slide, an example VSD is shown while a hotspot is being created. The element of interest is highlighted and then the communication option is configured. Automated communication options are being studied because manually creating options takes the communication partner's attention away from the conversation. However, previous solutions were limited in their ability to reliably generate conversationally relevant communication options. Generative AI may produce contextually relevant options, but they must be carefully examined given the prevalence of harmful biases and hallucinations in these models. We investigated the following research questions. How do communication options generated by speech-language pathologists, SLPs, AAC researchers, and a large multimodal model, LMM, compare in terms of focus and quality? What are the perceptions of SLPs and researchers who use VSDs on the use and ethics of LMMs for just-in-time programming of VSDs? We collected 78 sets of communication options from SLPs and AAC researchers in OpenAI's GPT-4 vision model. We had participants in the LMM generate communication options for 3 different contexts where VSDs are used: playing, reading a storybook, and retelling a past activity. We conducted 2 kinds of analysis of the content of the generated communication options: part of speech analysis, which looks at the frequency of each part of speech, and the function of the communication options based on Light's 4 function of communication: expressing wants and needs, information transfer, social closeness, and social etiquette. We saw a similar distribution in the use of the various parts of speech used by people in the LMM. Nouns and verbs were the most popular for both. We observed similarity in the communicative functions used by people in the LMM, both focused on expressing wants and needs and information transfer, with the LMM focusing more on information transfer. We saw a large difference in the LMM's lack of generating communication options for social closeness and sound effects, which fall into the other category. To analyze the quality of the generated communication options, we conducted a follow-up survey with a subset of our participants. They rated the communication options generated by the other participants and the LMM on a 5-point scale. The box plot on this slide describes the results of the rating task. Overall, the quality of human and LMM generated communication options was quite similar. We also conducted 5 semi-structured interviews with SLPs and AAC researchers with experience with VSDs. Through our interviews, we identified the following potential harms of generative AI and VSDs, which included the lack of personalization of LMM-generated communication options and developmentally inappropriate LMM-generated communication options. In conclusion, the communication options generated by the LMM and people were similar in content, focus, and quality, but differed in LMMs not using sound effects or language for social engagement. Some key concerns emerged through our semi-structured interviews. LMM-generated options currently lack personalization, and LMM options may not always be developmentally appropriate or may include biases and stereotypes. Future work includes an investigation into how to use communication partners' knowledge in the LMM generation process.